We're going to start the second part of this section by talking about how we're going to graph these rational functions. And there's a series of steps. And again, these can be longer, just like some of the other ones, because there's so many different parts to the graph. And you saw that kind of with some of the visuals of the other graphs that we did in the first video. They're discontinuous, they're going in different directions, there's lots of asymptotes. So you have this chart on your sheet. It's guidelines for graphing rational functions. And the first thing you're going to do is you're going to find any vertical asymptotes. And we learned how to do that in the last video. Second step is we're going to find any horizontal or oblique asymptotes. Again, that was in the last video. We're then going to try to find any y-intercepts. And we do that by plugging in 0 for x. We've done that several times in the past. We're going to find x-intercepts. And we're going then, step 5, determine whether the graph will intercept its non-vertical asymptotes. We're going to plot a few selected points and then kind of complete the sketches based on the points that we have. So let's take a look at the first one, number 4, which says graph f of x equals x over x squared minus 4. Now you'll notice the degree is higher in the denominator, so that's going to tell us it's going to have vertical and horizontal asymptotes and no oblique. But let's start with the first part, which says that we are going to find vertical asymptotes. So we take the denominator and we set it equal to 0. This one's factorable, x plus 2, x minus 2. So there are 2. X equals negative 2 and x equals 2. Next thing we're going to do is we're going to see if there's any horizontal asymptotes. And we do that again by dividing every term of the function by the highest degree. And in this case, it's x squared. So this is over x squared, x squared, x squared. And we see how it approaches infinity. This would reduce to 1 over x. And 1 over x, as x gets bigger, approaches 0. So you'd have 0. That cancels out to be 1 minus 0. So 0 over 1 is 0. So our horizontal asymptote is y equals 0. The next step says to find any y-intercepts. And to find any y-intercepts, what we're going to do is we are going to substitute x in for 0. So we'll have 0 over 0 squared minus 4. That evaluates to 0 over negative 4, which is just 0. So our y-intercept happens to be our x-intercept, which is at 0, 0. Number 4, or number D as I'm going to label it, is to find the x-intercepts. Well, you can kind of see by letter C that the x-intercept will just be 0, 0. Step number 5, which is, I'm going to label this E. I know they don't match up with the numbers, but you get the idea. It says determine whether the graph will intersect its non-vertical asymptotes. And we're going to solve this by f of x equals b, where b is the y value of the non-vertical asymptote. So in this case, if we think about it, this really means f of 0 equals 0. 0 equals 0. And yes, it does. If we look at the horizontal asymptote, those match up. So yes, it does cross it. Before we get to part 6, I'm going to start sketching a couple things. I want to sketch our vertical asymptotes. And I'm also going to sketch real quick our horizontal. If I had an oblique, I'd also do that. I want you to take a look though, and you can see that, again, there's really kind of three sections. There's one left of -2, there's between -2 and 2, and then there's greater than 2. And those are the kind of the three different parts of the graph. So what I'm going to do, and this is kind of that step number 6 where it says plot a few selected points. I'm going to kind of divide this up into three sections. I'm going to pick a couple points that are on the far left part, so something less than -2. And then I'm going to pick something between -2 and 2. And then I'm going to pick something greater than 2. And then that will give me some points that fall in this area of the graph, some that follow this, and then some in here. And that will give me kind of a good idea of what the sketch will look like. So less than -2, I'll use -4 and -3. And when I take -4 and I plug it into my function, you're going to get a value of -1/3. Again, I plugged it into the function, so it would be -4 over -4 squared minus 4, which is -4 over 16 minus 4, -4 over 12, reduce it down to -1/3. So you get the idea. So then I'm going to take -3, plug it in, and you get -3/5. I'm going to pick 2 points between here and here. So I'm going to do -1. I actually have 0, 0, so I'll put that in there, but I'll do 1 as well. When I put in -1, you're going to get 1/3. When you put in 1, you're going to get -1/3. And a couple numbers above 3, so I'm sorry, above 2, so 3 and 4, and you get 3/5 and 1/3. And from there, I will plot these points. So -4, -1/3, and then -3 and -3/5. And because we know that they're asymptotes, I'm going to just continue the sketch of that. So that kind of gives me an idea what the left side looks like. Then I'm going to come to the center and I have 0, 0. And at -1, it's 1/3. And at +1, it's -1/3. And again, I know these are asymptotes. So I'm going to kind of continue those patterns to reach my asymptotes. And then finally, 3 and 4. 3 is 3/5. And 4 is 1/3, so it's going down. So again, it's approaching the asymptote and then coming up. And if we take a look, that's our rough sketch. We can put into Desmos and hopefully we'll get something similar. And here's what it looks like in Desmos, which I think is pretty accurate. It's not going to be perfect, but I think it gives a good idea of what we did on the graph. So let's do one more together. We're going to go down the checklist and kind of make a sketch out of it. So the first thing we're going to do is we're going to start with a vertical asymptote. The vertical asymptote will come from the denominator again, x minus 2, which equals 0. So our vertical asymptote will be 2. Next thing we're going to do is we're going to do a horizontal asymptote. And again, this comes from y equals, and then I take each one and I divide it by x, because that's the highest degree. This is going to reduce to 3, the first term. This approaches 0. So again, this is all when x approaches 0. I'm sorry, approaches infinity. So as it gets larger, it's approaching 0. This reduces down to 1 minus 0. So our horizontal asymptote is y equals 3. And then we are going to find a y-intercept. And f at 0 equals 3 times 0 plus 2 over 0 minus 2. So that reduces down to -1. So our y-intercept is 0, -1. Next thing is to find our x-intercept. We can find our x-intercept by setting it equal to 0. So it's 3x plus 2 over x minus 2. So in order for this to be 0, that means the numerator has to be 0. So 0 equals 3x plus 2. So x equals negative 2/3. I just subtracted the 2 and divided by 3. So that is our x-intercept, which would be at a coordinate point of negative 2/3, comma 0. The next thing to ask is, does it cross the horizontal asymptote? Well, our horizontal asymptote is 3, so y equals 3, right? Y equals f of x. So does that equal our function? So I'm going to solve this, and if I multiply both sides by x minus 2, distribute, I get 3x minus 6 equals 3x plus 2, and then I subtract 3x on both sides. Negative 6 does not equal 2. That's so it doesn't have a place. So no, it does not cross. So I'm going to take my graph, and the first thing I'm going to do is I'm going to draw some asymptotes that I have. One of the asymptotes being x equals 0, and the other one being y equals 3. Now in this case, you can see that it only breaks it up really into two parts. One part right here, another part right here. So we have less than 2, and we have greater than 2. So less than 2, I'm just going to do some points. I'll do positive 1. I already have that 0 is negative 1. That was our y-intercept. And maybe I'll do negative 1 as well. So that's that first part. And then the next part I'm going to do is I'm going to do things greater than 2. So 3 and 4. So I'm going to take those, I'm going to plug those in. When we get 1, we get negative 5. When I get negative 1, I get 1/3. And when I plug in 3, I get 11. And I get 4, I get 7. So I'm going to start plotting those. So 1, negative 5. 0, negative 1. And negative 1, 1/3. And again, because these are asymptotes, I'm just going to kind of sketch this. Just a very rough estimate. I could probably add a few more points if I want to get it super accurate. And then 311 is going to be off of my graph. But 47 is right here. And we know that's going up pretty steep, and then it's going to come back down. Again, what I'm going to do is I'm going to go over to Desmos, kind of compare the two. And you can see the horizontal asymptote at 3 and that vertical asymptote happening at 2. And the basic shapes are there. I'm actually going to skip over number 6. You can certainly give this a try and then put it in Desmos to see how accurate your graph is going to be. But we're going to move on to number 7. And actually with number 7, I'm going to ask you to pause the video and see how much of it you could get by yourself. And then when you're done, unpause it and I will have all the information so you can compare everything. I will let you know in this case, because the degree is higher in the numerator, it will have an oblique asymptote. All right, you can take a look at what my vertical and my oblique asymptotes are. And I have them drawn in the red on the graph as well. I found out the y-intercept and the x-intercepts. And I made a t-chart here at the end, and I kind of rough sketched between the points.